This is geometry. This is the second day of notes for Unit 4. We're talking about the triangle sum theorem and particularly about the exterior angle theorem. With this exterior angle theorem, we're talking about how the outside angle, called the exterior angle, equals the sum of the two angles inside. The measure of the exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So looking here at our picture, the outside angle, the exterior angle, equals the two non-adjacent, not the one next to it, but the non-adjacent to one. The sum of those is going to equal the value of 1. So let's come try some of those problems. So here we have an exterior angle, and it's going to equal the two angles that are not next to it, non-adjacent to this exterior. So we know that 3x minus 9 is going to equal the two angles that are far away from that exterior angle. So we can subtract the x. We can add the 9. We get 82. And that's going to give us an x value of 41. They want us to find the measure of DCB. So that's the exterior angle. So we're going to say 3 times 41 minus 9. That's 123 minus 9. That's 114 degrees. The other way we could have done it, besides plugging it in here, 41 and 73 have to add up to equal that angle. So you get 110 plus the 3 and the 1, which is 114. On our second example, we take the measurement of angle ABC, which is apparently 47, the measurement of angle CAB, which is x minus 3, and the measurement of angle 7x, or ACD, which is 7x minus 4. Again, using the exterior angle theorem, we're using the concept that the exterior angle is going to equal the sum of the two non-adjacent to it. This is called the exterior angle theorem, that 7x minus 4 is going to equal the two angles that are not near this exterior angle. So we can just kind of collect like terms at first, that these two put together is going to make 44. We can minus x to give us 6x. We can add 4 to give us 48. So we know that x has to be 8. Now it wants us to find the measurement of BAC. It's kind of a funny angle here. So BAC is going to be x minus 3. So that's 8 minus 3, which is 5. Yeah, that doesn't look like 5. Apparently it's not drawn to scale. Because this angle doesn't look anything close to 5 degrees. But that's okay. The mathematics supported it. Alright, what do we see with example number 3? The first thing I would hope you would recognize is these two triangles. These two triangles tell us that the lines are parallel to each other. And if they're parallel, we should think of 4 different things. We should think about alternate interior angles, alternate exterior angles, corresponding angles, and consecutive interior angles. Whenever you see parallel lines, you should be thinking about one of those and looking for one of those types of angles. Do you see any of those? Well, we've learned that alternate interior angles are formed by a zigzag. So there are your alternate interior angles. If lines are parallel, which we have, then alternate interior angles are congruent. So if they're going to be congruent, they're going to be equal in measure. So we know that x has to be 43 degrees. And then using the exterior angle theorem, we know that the exterior angle, the angle on the outside of the triangle, is equal to the sum of the two non-adjacent angles. So 75 is going to equal 43 plus y. So we subtract the 43 over, and we figure out that y is going to equal 32. Sorry, 32. That's 32 degrees. So whenever you see parallel lines, you're looking for one of those types of angles. And then from there, you can keep working. Alright, here's some problem solving, trying to figure out what to do with the shape. We're going to find the measure of this exterior angle. Well, we know that 4 is going to equal the non-adjacent, the sum of the non-adjacent angles. But we don't know what that one is. It has 1 tick mark, which means it also has this one as 1 tick mark. That means that if it's a triangle and all 3 angles must add up to 180, 2 of them are the same. Let's call both of these an unknown amount called x. So we have x plus 50, and that has to add up to 180. Well, if you collect your x's together and subtract across your 50, you get 130. Then we'll divide by the 2, we get 65. So x is going to equal 65 degrees. So angle 4 is going to be the sum of those two added together. Or it's a linear pair with the one next to it, however you want to think about it. But 50 plus 65 is going to give us 115. Here we have 2 lines that are perpendicular to the same line. And we know that if 2 lines are perpendicular to the same line, then they are parallel to each other. So if these 2 lines are parallel because they're perpendicular to the same line, they have to be parallel, then we have corresponding angles, and corresponding angles are congruent. You can't just force things to be equal. You have to have a reason they're equal. So you got to figure out one of the reasons that we have to support that. And if the lines are parallel, then corresponding angles are congruent, works for us here. Okay, what do you see with this example? Do you see parallel lines? No, we don't have any parallel lines. But we do have an exterior angle and two non-adjacent angles, two angles not next to that exterior. So we know the exterior angle has to equal the sum of the non-adjacent angles together. So we distribute subtract the x across, subtract the 8 across, and x is going to be 42. We're going to figure out the value of the exterior angle. Then 2 times 42 plus 4, 2 times 46 equals 92. 92 degrees is our exterior angle. Alright, we've talked about this in class before. It's called a corollary. That's an addition. That's something that's brought from the triangle sum theorem. The triangle sum theorem says that the 3 interior angles of a triangle add up to 180. Well, if the 3 interior angles add up to 180 and one of those angles is 90, then the other 2 angles have to add up to 90. So if 2 angles are adding up to the same amount, then the acute angles of a right triangle are going to be complementary. That's telling us that the 2 angles that aren't the right angle have to add up to be 90 degrees. So on the flip side, we're looking at this right triangle, which has a right angle in it. So I know that if a right triangle, that's what we have, then that's an E, then the acute angles are complementary. So if the acute angles are complementary, then we know the measurement of angle A plus the measurement of angle B has to add up to 90 degrees. We're going to substitute in the 22 from the given and subtract that over. We find out that the measurement of angle B is 68 degrees. So here we have 22, and we solved for this angle. Some people just like to say 180, plug in your 90, plug in your 22, and you figure out that you get 68. You can also just treat that as both of these have to add up to 90. Here's a tough one. Got to look at this a couple different ways. Here we see this big triangle. Okay, that bigger triangle here has an exterior angle of 85, and it's going to equal the y and the 25. We call that the exterior angle theorem. That's what we learned earlier today. That the exterior angle, the angle on the outside of the triangle, when you extend the side of the triangle, you make what's called an exterior angle. That's going to be equal to the two angles that are not right next to it, that are non-adjacent to it. So y is going to have to be 60 degrees. And then if we look here, at that right triangle, we know that we have 60 degrees here. We're looking for the value of x. If a right triangle, then the acute angles are complementary. So that means x plus 60, or we could actually call it y, but we know y is 60, has to equal 90 degrees. So that tells us that the x value has to be 30. Here again we have a right triangle, and if we have a right triangle, then the acute angles are complementary. So we know that 5x plus 3 and 4x minus 3 is going to add up to 90 degrees. Here we get 9x. Here those are going to cross out because one's a positive 3, the other's a negative 3. When we divide, by 9, we get 10. So x is 10. The value of each of these angles is 5 times 10 plus 3. So we get 53 for that angle. And 4 times 10 minus 3. So we get 37 for that angle. And together they add up to 90 degrees. Right triangle. The acute angles of a right triangle are complementary. So 26 has to be our missing angle. We plug 26 in here, and we get 38 degrees is our missing angle. All right, our last one. Here we know a couple different things as we look at this. We know we have 3 angles. Those 3 angles have to add up to 180. But we don't know 2 of them, so we can't solve for that yet. We know that these 3 angles have to add up to 180. That's true. So the measurement of angle 1 plus 45 plus 65 has to add up to 180. So the measurement of angle 1 has to be 70 when you subtract 110 to the other side. So that tells us that this is 70 degrees. If this is 70, we get 115 for this full angle. That full angle there is 115, 70 plus 45. So 115 has to equal the measurement of angle 3 plus the 20. So this guy's got to be 95 degrees. And if that's 115, it's a linear pair with 2. So the measurement of angle 2 plus the 115 has to add up to 180. So the measurement of angle 2 is going to equal 65 degrees. So we did it. We found the value of 1, of 2, and of 3. Have fun with triangle angles.